There's a woodpecker right there screwing up my audio. I'll wait for this raven to go by. I gotta shoot that one again. Hold on. Hi everyone, this is Kent from Man About Tools, and this is a follow-up to my first video on casting your own concrete garden box panels. A year has passed, so I think it's time to see what improvements I can make. There was a ton of interest in that video, so I wanted to shoot a sequel and find a faster, easier, and cheaper way to build the forms and cast the panels. These reinforced concrete panels link together to create long-lasting, rot-proof garden boxes. If you haven't watched my first video, then please have a look to see my original plywood form design. There's a link to that in the upper right or in the description below, or go to manabouttools.com and see it there. I got a lot of comments and suggestions from that first video, and I was overwhelmed by the positive reaction it received, so thank you for your support and contribution. A bit later, I'll address some of the most common comments and questions I received, so stay tuned for that. I first made these plywood forms and cast panels about 8 years ago, long before I planned a YouTube channel. I was casting these for myself, so at the time I wasn't concerned that the forms be simple. I just wanted them to be reusable and for them to work. I'm not a professional form builder, so I'm sure there's other ways to cast these panels, but this is what works for me. Many commented that the forms were too complicated to build, so I decided to go back and look at my original design and see if I could simplify and improve upon it. I still want to cast the concrete panels in the same size and shape, so the new ones would connect and fit with the original ones. My original plywood forms work very well, so if you're already building yours that way, then keep at it. The new form design uses standard framing lumber instead of plywood. There's fewer parts and I've simplified the finishing. Instead of multiple coats of polyurethane, I'm using food-grade mineral oil to coat the forms. It's cheaper, faster, and easier to apply. I like it as it's non-toxic and won't go rancid like vegetable oil. You don't need a lot of tools to make these forms, and I'll show some alternatives as I build them. As before, I have a full set of plans available for download from my website, manabouttools.com. See the link here or in the description below. So here's the new form design I came up with. The base is made from a 2x10 with a beveled 1x4 as an inset. The ends and sides are made from a 2x6. The ends and sides have a peg made from wooden dowels to hold a pipe in place. The pipes are plastic electrical conduit with galvanized wire wrapped around them for reinforcement. There's 3 main parts to the form: the base, 2 identical ends, and 2 identical sides. When filled with concrete halfway, a stiff wire mesh is laid in for additional strength. I start by cutting a 2x10 to length, then ripping it to width on my table saw. This one will make a 48-inch long panel. I'm making 3 different lengths of forms this time, to cast a 48, a 36, and a 24-inch panel. I cut these to length with a miter saw, but a square and circular saw will also work well. To make the new forms the same inside dimension as the previous plywood versions, I ripped the 2x10 down to 8 inches wide. I use my portable table saw for this. A guide and a circular saw will also work. I ripped both edges on the table saw to give me a square corner on both sides. Framing lumber comes with a small rounded corner, and I want to remove this. After ripping, I do the final trim to the exact length back on the miter saw. After the base is ripped and trimmed to its final length, I'll lay out the end cuts and inset location. I'll remove the corner pieces with a jigsaw. You could use a handsaw or a bandsaw for these cuts instead. I checked the cut with a square. All looks good. The inset is an angled piece attached to the base mainly for decorative purposes. It's not functionally required, but I like the look. A 1x4, which is actually 3/4 by 3.5, can be used to make this. I had some slightly thinner 5/8 inch boards, so I used those instead. Either would work fine. I ripped these at 30 degrees on my table saw and cut to length on the miter saw. You could personalize your panels here by adding an oval, or circles, or a logo, or anything you want. Just be sure that whatever you use has a beveled edge so you can remove the panels from the base after casting. I attach them with glue and screws from underneath. If you don't use glue, then you can change the inset design in future castings. The sides are made from a 2x6. Like the base, they are cut to length on the miter saw. Then ripped down to width on the table saw. The sides are laid out and the hole for the dowels drilled. I use a Forstner bit for this, but any 5/8 inch drill bit would do. I use a small benchtop drill press, but you could carefully freehand this or use a drill guide. You want the pipe holder pegs to be at right angles, 90 degrees, to the sides. I like to pre-drill the screw holes as well. It makes assembly a bit easier later on. To make the ends, I cut a length of 2x6 for the 3 pieces that make up the end assembly. These are ripped on the table saw to width, then back to the miter saw to cut down for each component. One of these blocks I take to the drill press for the dowel hole. I'll then drill the pilot holes for assembly with an 1/8 bit. The dowels need to be sanded down to reduce their diameter to fit inside the pipe. I use a disc sander for this. You could also use a small hobby sander or a belt sander instead. These are then cut to length and glued and tapped into the holes. I assemble the ends with glue and screws, checking that everything lines up well and is square. A clamp helps hold the pieces while I run in the screws. With all the parts of the form ready, I assemble it and test the fit. I used particle board screws for this, but there's some self-drilling cabinet screws, for a few more dollars, that would save time and pre-drilling. I number each form and all the parts so I can reassemble it again the same way. I remove the screws and disassemble the form and apply 2 coats of food-grade mineral oil. This oil is sold as butcher's block or cutting board oil. You can also buy it from feed stores for about half the price. I liberally apply it with a cloth. It doesn't take long, and each coat took about 10 minutes per form. While this is drying or soaking in, I'll cut the plastic pipe to length. I use wire wrapped around the pipes to add strength to the ends where the concrete is the thinnest. I wrap wire around the pipe like a spring, then open it up a bit. With small bolt cutters, I cut a section of stiff wire mesh to reinforce the center section of the panel. This will be laid in the concrete as it's poured. Now assemble the forms with the wire and pipes. I add some latex caulking to make the forms watertight and to add a small fillet in the corners. I realized later that it's easier to add the caulking to the ends before the pipe is in place. This takes only a few minutes per form. This also fills any small gaps where the sides, ends, and base meet. Don't use regular silicone for this. It's too strong and will be difficult to remove later. I filled any knot holes or screw heads with a bit of wood filler. Some of the insets had holes pre-drilled from the other plywood forms. They were the right size, so I attached them with screws from the top. No worries, wood filler filled the screw heads and only took a few minutes to apply. I set the forms over sawhorses and level them in both directions. I cover the wire and pipes with a cloth and spray the form with vegetable non-stick cooking spray. I'm going to use crack-resistant concrete that has fibers added for more strength. It's only a few dollars more per bag, so why not? Some have suggested that fiber-reinforced concrete would be strong enough, so wire would not be needed. But adding the wire gives me an extra bit of insurance that doesn't cost much in time or materials. So I'm sticking with it for these castings. I mix the concrete in a wheelbarrow and shovel it into the form, filling it halfway. I use a wooden mallet to settle the concrete and bring bubbles to the surface. You can use the edge of an orbital sander or a recip saw without a blade to vibrate the forms. I lay in the wire mesh, then top up the form with more concrete. I'll let this set up for a bit, then come back with a corner tool to round over the edges on the sides. The concrete in the forms is covered with plastic and left for a few days. Now the screws can be removed and the sides and ends can be gently pried free. The newly cast panels should be kept wet and allowed to cure for about 4 weeks. The latex caulk can be easily scraped off with a putty knife, and the form parts wiped clean with a rag. I cut rebar into 1-foot lengths with a cutoff blade on my angle grinder. I clamp the long length of rebar across sawhorses. A hacksaw will work, but it takes a bit longer. Some building supply stores sell rebar pre-cut in shorter lengths as well. I level a spot in my garden and overlap 2 panels. I check the corners for square, then drive in the rebar through the corner and into the ground to secure them. I repeat this on each corner to complete the garden box. For deeper boxes, you can stack and alternate the panels if you like. You will need longer rebar for this. Here's a few different size garden boxes you can make using these 3 panel lengths. I would normally lay out and level the ground before setting the panels in place. But for this quick demo, I use some wood blocks instead. We put a layer of cardboard down over the grass, then fill the box with compost and soil before planting. So in this section, I'd like to answer some questions from the previous video and add some thoughts on casting these concrete panels. What about making the forms from melamine? I happen to like working with plywood, so that's the material I chose. But instead of plywood, these forms could be made using melamine-coated board. That's a really good choice for small formwork, and melamine doesn't require any finishing. I don't know about the longevity of particle board near moisture, but if you are only doing a few castings, then it should work just fine. Can you make the panels lighter? Many people asked about using lightweight concrete and other alternative materials to make the panels lighter. For me, the weight isn't a big concern, but enough people have asked about it that I decided to shoot another video covering just that, so look for that coming up soon. It seems that you have to sacrifice strength when you go to lightweight concrete, but it's worth having a look at, so I'll see what I can come up with. Be sure to hit the subscribe button and the bell to be notified when I post that. Can you make the panels taller for deeper beds? I decided on an 8-inch height for the panel, as it seems that you can grow just about anything in 8 inches of soil. A taller panel might get a bit too heavy to handle easily. However, these panels can be stacked to create deeper beds. How will these panels do in the winter? Another concern was the winter durability of the panels and how they might survive freeze and thaw cycles. The rebar that pins the corners together allows for a little bit of movement for expansion and contraction. You could also use a thinner rod than this rebar for even more play at the connection. The pipe holes could also be filled or capped to prevent water from pooling inside. A thin flexible gasket could also be added between panels to keep out moisture and add some flexibility at the joint. Can you move the garden bed after the panels are set and linked together? A washer could be welded to the top of the rebar to make it easier to remove it if you ever wanted to disassemble the panels and move the bed. There's pros and cons to both these designs. The new framing lumber version has fewer parts and is easier, faster, and cheaper to build than my original plywood forms. And I've also found that it's easier to remove the ends by gently rocking them. Plus, you can remove the base from the finished panel easier by tilting it up on its side. The plywood forms give a better finish, should last longer and have fewer, if any, knots. And plywood is not susceptible to the distortions of framing lumber. Framing lumber will have a greater tendency for warping, cupping, or twisting from the moisture penetration during the casting process. And I'm finding it harder to source good quality straight and true lumber these days. I try to be as accurate as possible when I'm building these forms. Doing so ensures I get a good fit in the final castings. So I hope you've enjoyed this video, and thank you so much for watching. There's a blog post for each of our videos on our website where I have written instructions and updates, so please have a look at those. If I make any further improvements or changes, I'll post those there. If you like this video, then please give it a thumbs up and subscribe if you haven't done so already, and hit the bell so you can be notified when we post a new video. We'll see you next time. And one last thing, I'm sorry about the music on that last video. That fretless bass was a little too much for some people.